There are wars that are decided by tanks, bombers, artillery, and fleets. And then there are wars decided by whispers, static, paper, mathematics, and time. During the Second World War, some of the most important battles were fought far away from beaches, forests, and city streets. They were fought in locked rooms behind blackout curtains by men and women who rarely fired a shot, but who learned how to steal the enemy's secrets before the shooting even began. This was the hidden war of cryptology. It was a struggle between machines and minds, between secrecy and analysis, between the confidence of dictators and the patience of mathematicians. And in that invisible war, information became a weapon as powerful as any battleship or bomber. If you value the machines, the minds, and the untold systems that shaped Allied victory, you are watching America at full power. And the story you are about to hear is not just about codes, it is about power. The power to hear an enemy before you see him. The power to know where he will strike before he gives the order. The power to turn silence itself into a battlefield. To understand this war of secrets, we have to begin with the German Enigma machine. To the men who trusted it, Enigma looked like the perfect fortress of modern communications. It was an electromechanical cipher device that scrambled messages through rotating components and changing internal settings, creating vast numbers of possible combinations. German commanders believed that once a message went into Enigma, it vanished into mathematical darkness. But the first great blow against Enigma did not come from Britain. It came from Poland. Before the war fully erupted, Polish mathematicians made crucial breakthroughs against the Enigma system and passed that knowledge to Britain and France in 1939. That handoff was one of the great intelligence gifts of the 20th century. When the war expanded, Britain turned a quiet country estate into one of the most important nerve centers of the Allied world, Bletchley Park. There, mathematicians, linguists, engineers, chess players, classicists, and puzzle solvers were gathered into an industrial-scale effort to read enemy traffic. Among them was Alan Turing, whose work became central to the effort to attack German encrypted communications. Turing and his colleagues did not simply guess passwords or stumble onto luck. They built systems. They attacked habits. They studied operator mistakes, repeated phrases, message formats, and the daily routines that human beings always bring into even the most advanced machines. And to exploit those patterns, the British developed the Bombe, a machine designed to test possible Enigma settings at speeds no human team could match. What emerged from Bletchley Park became known as Ultra. Ultra was not a single breakthrough. It was an intelligence pipeline, fed by interception, analysis, machinery, and relentless discipline. Its value was almost beyond measure. German messages about air operations, submarine deployments, and military logistics could now, under the right conditions, be read by the Allies. That mattered enormously in the Battle of the Atlantic. German U-boats were hunting Allied convoys, trying to sever the supply lines that kept Britain alive, and the future liberation of Europe possible. When Allied intelligence could identify submarine patrol lines or operational intentions, convoys could be rerouted, escorts repositioned, and catastrophe reduced. The Atlantic was still brutal, still lethal, and still uncertain, but code-breaking gave the Allies something priceless: warning. And yet secret intelligence came with a terrible burden. If the Allies acted too perfectly, too often, too quickly, the Germans would realize their cipher system had been penetrated. That meant intelligence officers and political leaders sometimes faced an unbearable choice. They had to decide when to use the information and when to let tragedy unfold in order to protect the greater secret. That was the moral weight of cryptologic war. Knowing, but not always being able to reveal that you knew. The Code War in Europe was only half the story. Across the Pacific, the United States was fighting a different enemy, across greater distances, over larger oceans, against a military machine that also depended heavily on encrypted communications. American cryptologic efforts against Japanese systems became one of the most important hidden campaigns of the war. One major American success came through work against Japanese diplomatic systems, including the cipher machine known to the Americans as Purple. The intelligence product built from these efforts became known as magic. This gave the United States access to high-level diplomatic communications and helped American leaders understand Japanese intentions with far greater clarity than the enemy imagined. But diplomatic traffic was only part of the picture. Operational naval code-breaking in the Pacific became decisive. American analysts worked against complex Japanese naval systems, including the code known as JN-25, and their success helped the United States identify major Japanese operations. That work contributed directly to the American ambush at Midway in June 1942, one of the turning points of the entire Pacific War. At Midway, foreknowledge did not remove risk, but it gave Admiral Nimitz something every commander dreams of having: the chance to prepare a trap instead of stumbling into one. The same hidden war of signals also shaped one of the most dramatic targeted operations of the Pacific conflict. In 1943, American intelligence intercepted and decoded communications that revealed the travel plans of Admiral Isoroku Yamamoto, the architect of the Pearl Harbor attack. Using that information, the United States sent long-range P-38 fighters to intercept his aircraft over the Solomon Islands. It was a striking example of how code-breaking could reach from a radio transmission all the way to a cockpit, and from a cockpit to history. But code-breaking was only one side of the equation. An army also needed secure communications of its own. And in the Pacific, where tactical radio traffic could be intercepted quickly, speed and secrecy were matters of life and death. That is where one of the most remarkable American wartime solutions appeared: the use of native language communicators, most famously the Navajo code talkers in the Marine Corps. Their communications system gave U.S. forces a fast, reliable, and highly secure battlefield method that enemy listeners could not effectively exploit. This is one reason the War of Secrets should never be reduced to one machine or one genius. It was a whole ecosystem. Mathematicians in Britain, signals intelligence teams in the United States, engineers designing machines to test possibilities faster than human hands ever could, radio operators listening through fatigue, static, and confusion, linguists, analysts, clerks, and couriers, each carrying one fragment of a puzzle too large for any one person to see in full. And perhaps that is what makes the cryptologic war so fascinating. It was modern war at its most industrial and most intellectual at the same time. Factories built bombers, ships, and tanks. But hidden institutions built something else: advantage. Not through steel plating or horsepower, but through patterns, memory, discipline, and machines of logic. The results were enormous. Historians and intelligence studies have long argued that Allied code-breaking shortened the war and saved countless lives by improving strategic decision-making and operational timing. It did not win every battle. It did not remove uncertainty. It did not make war clean or simple. But it gave the Allies a hidden edge at the highest level of conflict. And in a war of global scale, that edge could mean everything. When the war ended, the legacy of this secret struggle did not disappear with it. The cryptologic systems, analytic methods, and machine-based approaches developed during the Second World War helped lay foundations for the post-war intelligence world and the rise of modern computing. The War of Secrets had begun with paper, rotors, wires, and radio intercepts. It ended by pointing the world toward a future of computation, surveillance, and global intelligence competition. So when we remember the Second World War, we should remember not only the soldiers who crossed beaches, the pilots who fought in the sky, or the sailors who held the convoy routes. We should also remember the listeners, the mathematicians, the codebreakers, and the silent rooms where victory was shaped one intercepted message at a time. Because sometimes the deadliest weapon in war is not the bomb you drop, it is the secret you steal. If you enjoyed this documentary, hit the like button and subscribe to America at Full Power. And tell us in the comments which hit in front of World War II we should cover next.